Problem number 74. Sodium metal reacts violently when added to water according to the following balanced equation. So here's the chemical equation. You take sodium metal, react it with water. You get dissolved sodium hydroxide, but there's a lot of hydrogen gas that bubbles out. And chemists like to throw chunks of sodium metal into ponds and just watch the violent explosion of the hydrogen gas coming out of it. So, given this chemical equation, we're asked a few questions. Let's do them one at a time. So, starting with A. How many moles of water are needed to react completely with 3 moles of sodium? We see from the equation that 2 moles of water react with 2 moles of sodium. So it's a 2 to 2 ratio. Okay, and you should be able to see that if you have 3 moles of sodium, then it's going to be 3 moles of water. But the way that you kind of do these problems, if they involve calculations, is looking at the coefficients. This is a 1 right there. You can see that 2 moles of sodium reacting means 2 moles of water being needed. And you get this relation directly from the coefficients in the balanced chemical equations. These describe the moles of chemicals that are reacting, not the grams. They describe the moles. 2 moles of sodium react with 2 moles of water to give you 2 moles sodium hydroxide and 1 mole of hydrogen gas. So that's what allows us to figure out the answer. So starting with 3.0 moles of sodium, we can use the relation above to get from moles of sodium to moles of water. And we use it to build a conversion factor. So getting rid of moles of sodium, 2 moles of sodium, and then above we're going to have 2 moles of water. And you can see moles of sodium cancels, and you'll be left with moles of water. And this is simple calculation. 3 times 2 over 2 is just 3.0, but the units are now moles of water. So that's the answer to A. And for B, we are asked how many moles of hydrogen are formed from this many moles of sodium reacting. So this time we have to look at hydrogen and sodium, and we see from the chemical equation that 2 moles of let me put this in black. 2 moles of sodium reacting means 1 mole of hydrogen being formed. So it's a 2 to 1 ratio this time. And if we're reacting 0.38 moles of sodium, then we can use the relation above to get from moles of sodium to moles of hydrogen. And turning that relation into a conversion factor, we got 1 mole of hydrogen on top, and we're getting rid of sodium, so we put that on the bottom. 2 moles of sodium, and moles of sodium cancels moles of sodium, and we're going to end up with moles of hydrogen. So what's 0.38 divided by 2? 38 over 2 is 19, so it's going to be 0.19. 0.19. Sig figs work out. Okay, 2 sig figs. And for the last one, we're dealing with, what is it asking? How many moles of hydrogen So 1 moles of hydrogen, again, are formed from 3.64 moles of water reacting. So now we got to look at water and hydrogen. And we see that 2 moles of water reacting means 1 mole of hydrogen being formed. So we can get from water to hydrogen, and if we're reacting 3.64 moles of water, then turning the relation above into conversion factor, moles of hydrogen on top, moles of water on the bottom, and we see the moles of water canceling. We're left with moles of hydrogen, and what's the, oops, put this in black. What's the calculation? 3.64 over 2. So that's going to be 1.50 plus 0.32, 1.82. A little bit of mental math. And this will be a 3 sig fig answer this time, because 1, 2, 3. The coefficients in the chemical equation are unlimited sig figs. These are exact numbers. So we're going to be left with 3 sig figs for the answer, and there you go.